Now for today, we're going to learn how to solve logarithms using conversion of logarithm to exponential. Now we know that in the law of exponents, if we have x raised to negative n, we can change it into 1 over x raised to n. So our exponent will change into a positive number. So if I have x raised to negative 2, I can change it into a positive exponent by using the law. So now I have 1 over x squared. Similarly, another law of exponents that we're going to be seeing and using today will be the fractional exponent. If I have x raised to 1/2, we know that x raised to 1/2 is square root of x using the law of exponent. And every time we see an exponent of 1/2, let's say 4 raised to 1/2, it's the same as seeing square root of 4, which is equal to 2. This particular concept of law of exponents for negative exponents and fractional exponent is what you're going to see in some of the expressions that we're going to be solving in problems 1 through 9. So let's start with problem number 1. So problem number 1, I have logarithm of 64 base 4. Now, logarithm of 64 base 4 is something that is a little bit foreign to all of us. So let's change it into something that we are more familiar with, and that is the inverse of log, which is exponential. So by equating this to, let's say, a box, how are we going to figure out the number in the box? And to do that, we're going to convert it into exponential. So now we have 4 raised to something equal to 64. So we just need to figure out a way using mental math and our skill in remembering the times table or multiplication table to find the exponent of 4 that will give us 64 when we look for it. Now, using the calculator, we can do a trial and error. Now, I'm just using the calculator to show you the progression of the exponents. Let's say we are looking for 4 raised to 2. And 4 raised to 2 is equal to 16 because 4 times 4 is 16. So 2 is not the exponent that we're looking for. Let's say we're looking for or using 4 raised to cube. 4 raised to cubed is equal to 64, which means the exponent that we're looking for is 64. So the number in the box is equal to 3. So that is how we solve logarithms using exponents. So we're going to use the same idea in answering problem number 2. So logarithm of 216 base 6 equal to something. So let's try a different approach. Let's change it into an x. So by using x, we can still convert this into exponential, which will give us 6 raised to x equal to 216. So the exponent that we're looking for, which is x, cannot be 2 because if it's 2, 6 squared is 36. So if we use 6 times 6 times 6, which is 6 raised to 3, we will have 216. So that means the exponent that we're looking for is also 3. So with that, we can also answer problem number 3 this way using logarithm of 16 base 4 and equate it to x. So when we convert it, we'll have 4 raised to x equal to 16. Now, this time, x will be a lot easier to solve because we're more familiar with the squares of numbers. So we know that the number we're looking for is 2 because if we raise 4 to 2, it will equal to 6. So that's how we solve problems involving logarithms. Now let's answer the next set of problems, and you will notice that we have fractions in our logarithms. When that happens, most likely we will be able to associate this law of exponent in answering problems 4 to 6. So let's start with number 4. I have logarithm of 1 over 25 base 5. I will equate it to x just like the 3 problems that I have. And I'll have 5 raised to x equal to 1 over 25. Now we're going to do a little bit of mental math right here, because we know that if we raise 5 to 2, it will be equal to 25. But we're looking at the reciprocal of 25. And to be able to perform that particular operation, we're going to be using this rule. So if I have a negative exponent, I know I will end up with its reciprocal. So if I have x raised to negative 2, I will have 1 over x raised to 2, or positive 2, which is the reciprocal of my expression right here. So if I have 5 raised to x, I know that x should be negative 25. And the reason why it's going to be, negative 2. So if I change this to negative 2, I'll end up with 5 raised to negative 2. And 5 raised to negative 2 is 1 over 5 squared. To make it a positive exponent, I'll end up with 1 over 25, which is the same as the number we are looking for. So it's safe to say that whenever we see a fractional value in our exponent, most likely we're going to be using a negative exponent. So let's go ahead and try it with problem number 5. Logarithm of 1 over 27 base 3. Let's equate it to x. So when we convert it, we'll have 3 to the x equal to 1 over 27. And since we're looking for that exponent, we know that if we raise this to 3, 3 times 3 times 3 is 27. And since we need the reciprocal, we need the negative value of that exponent. So we have x is equal to negative 3, because if we have 3 to the negative 3, it will turn into 1 over 3 squared, which is, 3 cubed, which is 27. So for number 6, the last one in the set, if we have logarithm of 1 over 16 base 2 and equate it to x, we can change it into 2 to the x equal to 1 over 16. And the exponent that we're looking for is going to be negative 4, because if this is negative 4, it will turn into 1 over 2 to the 4, and it will equal to 1 over 16. Now that is the third set in our examples. Now, the second set in our example. Now let's try answering the second set. So on the second set, we have third set, we have logarithm of 5 base 25. Let's equate it to x, so we can convert it into 25x equal to 5. Now, you will notice that we have 25 raised to an exponent, and we need to make it smaller. Now, we know logically that every time we have an exponent, it will always grow bigger. But since we need to make it smaller, this time we know that we are going to be using fractional exponent to make our value smaller. So remember when we had square root of, or x raised to 1/2, it's the same as the square root. And if we have x raised to 1/3, it's the same as the cube root. So this same concept is what we're going to be using for this problem. Now we know that if we raise 25, or 5 raised to 2, it will be equal to 25. And since we need to change this x to make it look like 5, most likely 25 is going to be raised to 1/2. Because if we raise 25 to 1/2, we can change the exponent of 1/2 into square root, which gives us 5. So the x that we're looking for right here will be 1/2, because that is the exponent that will make 25 equal to 5. Now let's answer number 8. And we have log of 2 base 8 equated to x, so we can have 8 raised to x equal to 2. Bigger number raised to x equal to 2. We know that if we raise 2 to 3, it will equal to 8. And since we are looking for a fractional exponent, 8 will be most likely be 1 over 3 for it to be equal to 2, because the cube root of 8 is equal to 2. So x is equal to 3. 1 over 3. So we have 1/2 for the number 7, we have 1/3 for number 7, and they are both fractions because we're trying to make the number smaller given a number with an exponent. So with that, problem number 9, if I have logarithm of 3 base 27 and equate it to x, we'll change it into 27 raised to x equal to 3. Bigger number raised to an exponent equal to a smaller number will be a number that will be fraction, or exponent that is going to be a fraction. And we know that if we raise 3 to 3, it will be 27. So our fraction or exponent will turn into 1 over 3 because the cube root of 27 is equal to 3. So x is equal to 1/3. And this is how we evaluate logarithms.